Hi, I'd like to describe the sample programs for the Kafka 0.9 API. There's kind of a dearth of example programs out there for the new 0.9 API, and I'd like to help fix that. So this is a GitHub program. MapR Demos is the GitHub account. Kafka Sample Programs is the repository. And you can go there, you can read the README, and you can download the code. I'd like to walk you through how to do that, how to use it, how to work with it. So, first of all, let's walk through how you work with this code. So, what you do, first step, is you need to clone this repository. Here I'm copying the URL, and we can go to temp. I have a previous version of it there. Let's clean that up. And let's clone the repo there. Okay, so that has a license, a README, a POM, and source code. Now, following the directions in the README, we get down there, we need to download Kafka. Now, the way to do that is you go search for Apache Kafka, and then follow the link to the downloads. When you download the current binary release, this is the one I downloaded, 2.11 Scala compatibility. That'll take you to a page that shows you all of the download links with a suggested one that's close to you. I did that previously, and so what we can now do is extract the contents from that downloaded tar file. There we go. Now that's created a directory, this Kafka 211.091.00 directory, and we can go inside that, and looking at the directions again, we can start the server. First, let's start Zookeeper. I'm going to start it in the background so we don't have to worry about whether or not it's running in the foreground, and we don't have to waste windows on it. So there it started. There's a little bit of logging that happens. Next step is to start Kafka itself. Kafka depends on Zookeeper for various coordination functions, like keeping track of who's handling which topics and so on in each connection group. We don't need to worry about the details. We just need to think about Kafka itself as a single thing. So let's start Kafka. And again, we see a number of logging things. The most important thing here is, there we go, is we see Kafka started. The new leader is number 0. So we now have Kafka running. All of the logging messages for Kafka will appear in this window. We'll see them in the background as we're doing other things. Next step in the README then is to create topics. We're going to create 2 topics, one called fast messages, the other one called summary markers. Topics are where, we need to go into the Kafka sample programs and then the Kafka directory. Topics are where messages reside in Kafka. We're creating here a topic called fast messages. It has one partition, meaning there's no possible parallelism among a single consumer of the topic. It has a replication factor 1. That makes sense since we only have a Kafka cluster with one broker in it. So here we go. We just created that, and you saw a couple of messages fly by from Kafka and creating that topic. So let's go ahead and create the other topic, summary markers. Okay, So we've created the second topic now. And from here, what we want to do is take a look and make sure that we got the topics that we want. So here we're listing all the topics on the broker, the Kafka broker, and we see two topics, fast messages and summary markers. We saw, again, log lines appearing. This command, Kafka topics, connected to the Kafka server, got the information. That's why we saw the log messages. So we're doing right along there, coming right along. Let's do some of the real fun stuff. What we're going to do now is we're going to go up a directory. That's out of the actual Kafka directory back to the Kafka sample programs directory. And we're going to compile the code that's found in the source directory there. This is a Maven project, so all we have to do is say Maven package. That'll spit out a whole bunch of log lines. It'll probably send out more on your system than on mine because it'll be downloading various packages. Now, this creates in the target directory this file Kafka example. Kafka example is an executable program that embodies both the producer and consumer sides of this equation. I can start it by saying Kafka example producer, and that will produce messages. That, in fact, is the next step in the README. That is to produce a bunch of messages. As this runs, you can see it's printing out every time it sends out 1,000 messages. Already 1/3 there's 500,000. Now the program itself is designed to send 1,000,000 messages and stop. So Kafka now has 1,000,000 messages. Let's look at the code that produces that. That's the producer here. It's got a main program. It pulls properties from a properties file. Here's the properties file. The properties file says, here's how you get to Kafka. Here's the durability policy to be used, how many retries to be tried when things fail, how many bytes should be in the buffer before it starts sending things, how many milliseconds it should wait before it starts sending messages out, and which serializers to use for the buffer for the messages being sent. Now, importantly here, we have it set so that it'll block if it fills up on messages. That's a good thing to do for reliability. So we sent our 1,000,000 messages here. So let's go to the Kafka sample programs directory again. Now over here, what I'm going to do is run Kafka example consumer. Now, this may surprise you a little bit. We have 1,000,000 messages pending in the Kafka broker, but when we run this, aside from a little bit of logging from Kafka, we see no messages. Now what happens here is the first time we run it, it is, and we can look at the code again, this is the consumer code, these are the consumer properties. First of all, it uses the consumer, this is the consumer group called test. So the first time we run this client, it will initialize the consumer group called test, and it will set it to the end of all available messages. So let's stop that for now. Let's send in another 1,000,000 messages. This is our second 1,000,000. And now that we've started that, got that going, let's start the consumer again. And Shazam, there goes the consumer receiving 1,000,000 messages. It's faster than the producer, which is good. I mean, that's how we catch up with everything. And we can see here that it started out about 12 seconds behind. If I scroll back toward the beginning, we can see that it was considerably further behind. This is 1,000 messages back then, and the latency was 7 seconds. Now, the latency couldn't be 0 because I started the consumer after the producer had started. If I scroll now down to the bottom, the most recent messages, we see that the latency for 1,000 records at a time dropped to about 3 seconds. That's because the consumer got to the end of the million messages about 3 seconds after the producer had finished sending those. But if we send more messages, watch what happens. Boom, there's the producer, and immediately the consumer starts consuming messages. And we can play some games here. Like if I pause the consumer there and then start it up again, what we see there is when I pause it, I'm not sure I paused it at just the right time. No, there were still no more messages coming. I'll pause it here. You'll see the latencies increase suddenly. And then as the consumer catches up, you can see the latencies drop back down into the single or double digits in milliseconds. So this is kind of fun because we can start and stop it. If we stop it for a long time, or let's kill it. So we killed it at about 100,000 messages in, maybe actually about 200,000 messages into the 4th million. And look, the Kafka broker has noticed that the consumer group test has its consumer has died. Well, we killed it. And about 10 seconds after we killed it, Kafka noticed that. If we restart it now, what will happen is it'll light back up and continue processing messages from the point that it was, or at least the last point that it had committed before it died. And so that it just picks up continuing processing messages. It may process a few messages twice because when it committed that it had processed messages was probably somewhat delayed relative to when it had actually processed them. This is at least once message processing. But you can see here that everything's working correctly. If I kill it again and restart it again, notice there's a bit of a delay here because it takes a few seconds before Kafka decides the old one is dead. But once it decides, then things continue and off we go. So these are the sample programs. Let's look at them again. The producer here produces 1 million messages that are called fast messages. They're a JSON structure that's produced with the actual time the message is emitted. The type is test for most of the messages. Every 1,000 messages, we produce a message of type marker. And we also emit something to the other topic, the summary markers topic. And we put something out on the standard output. The consumer is quite simple as well. It creates properties from its own properties file. If there is no group ID, it makes one up. Then it creates a Kafka consumer object, which it then subscribes to both fast messages and summary markers. Then the process on the consumer side is that we get messages with a short timeout. If we got no records at all, we increment a timeout counter. When we finally do get records again, then we say that we got records with however many timeouts. That's just diagnostic, it's handy. And then depending on what, we iterate through all the records, and depending on the topic of each of the records, if it's either from fast messages or from the summary markers, and we're ignoring the summary markers messages right now, then depending on the type, if it's a test, what we do is we compute the latency, which is the difference from the current time minus the time the message was emitted. We record that into a histogram, both for the last 1,000 records and for all the records we've seen. If we see a marker message, it's different. What we do every time we see a marker message is we put out the per episode statistics, both the min, max, average, and 99th percentile, and we put out the overall statistics. Now, of course, the messages are ordered because they're in the same topic, in the same partition, So since the producer emits markers every 1,000 records, we'll receive them every 1,000 records. We can see that if we look here, we can see that every time one of these episodic summary messages comes out, we get exactly on 1,000 messages in the summary. So there you go. This is a very simple pair of applications which are for using the Kafka 0.9 API. The README has all the commands you need, and it talks about everything that we've shown in this video, including messing around with the consumer. The final thing there, which I haven't talked about, is a little bit of an odd behavior the consumer can get into if we decrease its buffers a lot, and how to clean up after we've run this. It's always nice after we've emitted millions and millions and millions of messages to delete all that. So there you go. It's their sample programs for the Kafka 0.9 API. I hope this helps. I hope you find it useful. Thanks very much.